and the colors were bad, so I didn't change them, so they're really better colors. Alright, 21b is Pearson's correlation coefficient. So on Thursday, when we talked about correlation, we said it was strong, moderate, or weak. Today, we'll actually be able to assign a number to that correlation to help us determine if it's strong or moderate or weak. Did everybody get the setbacks? Go back to our title as well if you guys didn't have a chance to write that down. All right. So as we get started, as I was mentioning, previously we estimated the strength of the correlation. Today we'll use a formula to get a precise measure. So Pearson kind of experimented with this stuff and figured out that we can get that correlation coefficient by this large formula. Number one thing to recall, or not recall, but see, is that R stands for Pearson's correlation coefficient. So if you have a question that says find R, find Pearson's correlation coefficient. Also, when we do use technology to calculate this, it does say R on your calculators. So when you're looking for that correlation coefficient, it is R. So the formula looks a little scary, but if we kind of break down all those pieces, I think you'll realize, besides the fact that it's like a whole lot of work, it's not that bad. So do we remember what X bar means? X bar? Okay. Yeah, it's the mean. It's or average. So where you see X bar, it just is the average of all the X values. So what do you think Y bar means? Absolutely, the average of all the Y values. So we know how to calculate X bar and Y bar. We add all of them up, divide by how many. We know how to do that. We also know how to subtract, lots of subtractions. We know how to square things, so we can square things. And what does sigma mean here? Sum. So, for example, for the numerator, once we calculate all these values and we actually multiply those values, then we have to add all those values up, and that's what goes in the numerator. Here, once we square it, add all the values, square it, add all the values, multiply our answers, multiply those sums, and then we have to square root it. So it's a lot. Like, it is a lot of steps, a lot to do. You will have to calculate one of these by hand on your assignment, but then from here on out, the expectation is that you use technology. So while you do need to know how to do it, don't panic about it. Now, we need to figure out, so what? We get this number. What do these numbers even mean? I keep forgetting that I say this before I have a slide, but there we go, by hand and technology. Now, what do these numbers even mean? So the values of R range from -1 to 1. So once you do all those calculations, or once you plug it into your calculator, the smallest number you can get is -1, the biggest number is 1. The sign of R indicates the direction of the correlation. So when we talked about direction, we talked about two different directions. Do you guys remember what those were? The direction? It can kind of go upward or go downward. So if our data was going upward, what would we call that? Positive. So a positive number indicates a positive correlation. So if you end up with any positive, not any, but most positive numbers say that our data will be trending upward from left to right. But another way to think about it as well is that an increase in one value will result in an increase of another value. Similarly, if we get a negative number, that means it's a negative correlation. So another way to think about that one is that An increase in one will result in the decrease of the other. So like as my x values are getting bigger, my y values actually get smaller with a negative correlation. But I mean, it's pretty easy to see without even graphing it. If I get positive value, it's going to be upward or positive direction, negative value, downward or negative direction. Yep, besides being able to tell if it's positive or negative, looking at that number can let us know how strong that correlation is. You know, like I said previously, we just looked at it, how those points were spread out, and we were like, oh, it's strong, it's moderate, it's weak. Well, we actually will be able to use the numbers to tell us what is what. So the size of R indicates the strength of the correlation. So if we have values that are close to positive 1 or negative 1, that indicates a strong correlation. So 0.9, it's going to be a really strong correlation. 0.8 is only going to be strong, actually to moderate sometimes. So kind of looking at that, those numbers that are 0.8, 0.9, or negative 0.8, negative 0.9, those will be strong correlations. Because remember, the negative just tells us the direction. If you have a number closer to 0, that indicates a weak correlation. So if you have like 0.2, 0.3, negative 0.3, negative 0.4, those would be pretty close to 0 and indicate a weak correlation. Now, in your textbook, there is a chart, which I'm going to display next, that really kind of outlines different intervals and the strength of correlation. So it's really helpful to like refer back to that chart. They also have pictures for every single like type of R value that you might get to kind of get used to like what's strong, what's moderate, and so on. So here's this chart. If you want to jot it in your notes, leave some space. I'm not going to stay on it for too long, but it is in your textbook. So if it actually, R value equals 1 or negative 1, that's called a perfect correlation. If it's between 95 and 1, or negative 95 and negative 1, it's very strong, or not 95.95. A strong correlation is only between 9.5 and 8.7. And then look at the range here for moderate, 8.7 to 0.5. So it's a really wide range of only a moderate correlation. If it's less than 0.5, we call that a weak correlation, or less than negative 0.5. I know I've been talking in the positives mostly. But if it's actually less than 0.1 or more than negative 1, like not close there at all, we aren't even going to be able to say there's any correlation. It's just completely like random, so no correlation there. So definitely refer back to this chart as a guide. Okay. All right. So we're gonna just talk a little bit about parts of this, and then I'm gonna have like a filled-in chart that we'll talk more about. So I think I need to zoom in a little bit here. So here we've got some data, and the data is the length of time customers were in a clothing store and the amount of money that they spent. So when you are calculating your coefficients, your Pearson's coefficient by hand, these are the things you need in your table. So I would at least write down all the different columns you need in your table. You need the X and the Y column. So in this case, time is our X, money is our Y. So you need an X column and a Y column. And then you need a column for X minus X bar and Y minus Y bar. So you need a column for all of those subtractions, so the X's and the Y's separately. I don't care if you like change the order of your columns or anything. I'm just using what was suggested in the book. Then they have a column for the product of both of those differences. So once you do these subtractions, you multiply these two and end up with this column in the middle, that product. You need x minus x bar squared for a column and y minus y bar squared for the column. Now, I left a row blank at the bottom for our sums. And so again, this is a lot, and like the one that you have to do in your notes only has like 6 data values or something like that. So this one's got like 15, so it's like a lot. So don't worry, we're not gonna have time necessarily to do the entire thing right now. But again, I did leave some space for the sums down here in this whole row. So here's my first mistake. Here's how I messed up all of my data is I added these up wrong. The very first thing I did, adding the x values, I messed up. What do you think is probably the most likely thing I did? I mean, how would I mess that up? I'm just adding things. Skip one, punch a number wrong, like read an 8 but punch a 5, like because they're right below each other. Like that's why we don't end up doing these by hand too often. But when we add them all up, we get 199. And then when we add up all of the y's, we get 856. So just as a reminder, when we calculate the average, we take the total sum divided by how many. So for x bar, we get 13.3. And for y bar, we get 57.1. So let's just fill in that first row just to get some idea of how that works. So then we have to take 8 minus 13.3. So 8 minus 13.3, we get negative 5.3. So does that make sense where these numbers are coming from? Then for y minus y bar, I have to take 40 minus the 57.1, so I get negative 17.1. So I just did those subtractions. Notice I had to calculate those averages first, and then I did the subtractions. Can I pencil down? Wait, I know there's a lot to write down. We are going to have all the numbers on the next page too. Then I have to multiply these two values to get this column. So negative 5.3 times negative 17.1, 90.63. When I take negative 5.3 squared, I get 28.09. And then when I take negative 17.1 squared, I get 292.41. So most of those columns were in our standard deviations. We've had some practice doing that type of math. The next slide is going to have all of the columns filled in for us. But are there questions on how to get these numbers? In retrospect, I should have chosen some data that wasn't so long. Whoops. But any questions about the columns? Okay. And so this is where I'm pretty sure I made some error somewhere, but we'll still be okay. All right, so here's the same table, all filled out except for I don't have the sums put in here. So remember, these are the sums. So that was 199 and 586. So the only sums we don't really need are these columns. Like, we don't really need to know the sum of the x minus x bar or the y minus y bar. Can you guys help me out? Maybe we get like this group over here to calculate this middle column and add up all of these? Can you guys do that for me? You guys add up that middle column. This is only a few people here, but can you guys add up the x minus x bar squared column? Right? And then what do you guys think I'm going to ask you to do? The last column, y minus y bar squared. Maybe I can find my error, but it might not. My error might already be up there. What? And it's helpful if like more than one person does it, so then we can see like, okay, maybe someone pushed a number wrong, maybe someone didn't. Whenever you're done, feel free to let me know what you got. You might notice, I probably should talk while you're doing it, but like your calculator can't even handle all of the data at once. It's like you have to do half of it and then like keep adding like the other half of it. Okay, we need another person with the middle. Once you guys get there.
I got 636.52.
Okay, I got 636.55. But again, so don't put that. Anyone over here? Wait. You guys got the exact same thing, so it must be. So don't clear it up. Don't clear it up. Okay. So we got two with the exact same. Found one error, I think. Okay, that's hard to read, but I'll write it up again. You got 5.5 also? So we're gonna stick with us then. We had two people with that one. If you can't see them in the chart, I'm gonna be writing them bigger elsewhere, so that's okay. Joe, what did you get? What did you guys? 254. Okay. We're gonna write them bigger. So in the numerator, Carrie, help me out. 84? Yeah. I'm already on the next. This is what I mean. My brain is like faster than my hand all the time. All right, and so then the x minus x bar, we got 636.55. And then the y minus y bar was 25242.54. Double check me, ladies. So as we can see, we've all had like some discrepancies. So one thing you'll notice, this this isn't in your packet. This crazy long formula isn't in your packet. So what I'm hoping you guys see that means is that we do want you to be using the calculators. We do also want to teach you by hand, but you will be using the calculators primarily. Like I said, you're only going to have to do one of these by hand. So then we can start evaluating. So I'm going to just evaluate my numerator real quick, just to see what we got going on there. And see, it's so easy to put your numbers in. Like if you have any sort of like mixing up of numbers, it's just really easy to make that happen. So after I square rooted it, multiplied it, and square rooted it, I wonder if this will fix my error, you guys. I'm real happy if it does. We're close. This is the best I've been all day. All weekend. All weekend, actually. So I was working on this all weekend. All right. So that's our correlation coefficient. 0.87 is. Wait, did I write it down right? No, this is actually not good. This is pretty bad. This is way worse, actually. Goodness gracious. So as we can see, there are issues with calculating by hand. Alright, so something went wrong, and here's how I know. Remember that this is all recording, so if you missed something you wanted to write down, you can get it online later today. But here's how we would, forget the step backs. I wanted you guys to manually describe it. It's a whole ton of work, right? We just describe it like that. We know what we're doing. We have to find the average, we have to subtract, we have to get products, we have to get squares, we have to add everything up, and then use our formula, which includes the square root and dividing. Here are the directions for how we would do this on a yellow calculator. So you guys know how you go into data, you would plug all of these values in. Now, instead of when you go back to stat, I think I skipped a step on my notes here. When you go to stat here, you have to select two of our stats because you have two variables. And then, make sure that L1 and L2 are highlighted for your X and your Y's. Once you go down to calc, it'll give you a whole bunch of stuff. And then the very bottom, it says R. And here's how I know we didn't do so good, is that the R value is 0.825. So whatever error we made must have been way worse than the error I made earlier. Because I was only off by 2 thousandths earlier today. But we're okay. We'll figure it out. I also have directions for TI-84. If you are that kind of person, I'll put them up in a little bit. Here's your assignment. Oh my gosh, something is just so wrong. Yeah. If you are a TI-84 person, here are your directions for how to use the TI-84. You can still see the assignment. I feel like I should just title today's notes Complete Hot Mess.